fan आपलं. Hi viewers, in today's class, I'm going to discuss on microstrip or patch antenna. So in the name itself, which is showing micro means a small size of antenna. So earlier in 1950s itself, this antenna has been emerged, but by 1970s, the development has increased enormously because of the demand of portability and handheld devices. Let's get into introduction of this antenna. So this antenna is also called as patch antenna. Why this name has been given means by seeing the structure of this antenna, you can understand. And in for this antenna, there are certain things which you need to keep in mind. Sorry. So for this antenna, we need to keep certain things in our mind. The first one is low cost antenna. The second one is low profile antenna. And the third point is which can be easily fabricated and it can be printed very simply on a circuit boards. And it is compatible with MMIC's technology also. And most important thing is these antennas are operated in the range above 100 megahertz. So these patches are available in different shapes like rectangular, square, circular, triangular in so many geometric forms. Out of all these, the rectangular patch antenna is very popular. The diagram I have shown here is regarding a rectangular patch antenna only. Based on the shape of this patch, that antenna's name has been provided. And next, this patch antenna is basically made up of a conducting material. Usually, most of the antennas, as usual, made up of copper. Here, this strip antenna is also made up of copper. And additional to this conducting material, here we will be using a dielectric substrate also. Usually, Teflon or epoxy glass or air, these can be choices for our dielectric substrate material. And another one is ground plane, again a conducting material. And here a patch antenna is just formed using these three elements. One is patch, dielectric substrate material, and a ground plane. A very simple construction. And here this patch and feed lines are placed onto this dielectric substrate using the photo etching process. You can see in this diagram. From this end, a feed line is provided into the patch. This patch is placed on the substrate and the substrate is placed on the ground plane. So this is the structure of this microstrip patch or patch antenna. Here usually these patch antennas are used in array concept also, where you can see some thousands of the small patches will be placed one by other and a big antenna will be array antenna will be formed. And here these antennas input is nothing but through coaxial cables or transmission lines which act like a feed lines are provided to this patch. Excitation to antenna is through this feed lines. See here, excitation is nothing but like feeding input to the antenna is given by this feed line which is directly connected into the patch. Here, one important point we have to keep in mind is impedance matching between these two is very important. Where in this diagram, you can see at the center, this patch is connected to feed line, but there is no such a rule that it should be at center. It can be slided in any of these two directions such that impedance matching can be achieved. So once impedance matching is achieved, then the feed line can be kept as fixed. The dielectric is used to separate patch from the strip of the ground. That is nothing but in between the dielectric is placed. Say here we can easily understand this structure with the help of this concept. See here I am giving here positive, here negative. And this is a conducting layer and this is another conducting layer. Dielectric is placed in between. So which is acts like a non-conducting metal. non-conducting material. This is acting like a conducting material. And here this is the patch and this is a ground plane. Between these two, dielectric non-conducting is placed. Here one point we need to understand. Whenever a non-conducting medium is separated by two conducting mediums, an electrostatic field is formed in between them. Because of this field, as we start providing supply from the external, as we start providing supply from external source, automatically what happens is electric field is created between them, which leads to the magnetic field. And the changes in these two causes production of the electromagnetic wave. As we know, this electromagnetic wave comes out in the form of a radiation. So this radiation is essential for any antenna mechanism. So this patch antenna with this simple construction acts like simply a radiating element. So coming to designing of this patch antenna, here the entire operation of patch is decided by its shape and size. So here you can watch majorly three things. One is width of antenna, length of antenna, height of the substrate. And here epsilon r is nothing but the dielectric constant value. So here you can see from this diagram, these three key elements are the entire deciding factor of the bandwidth, frequency of operation, and everything regarding this antenna. So first of all, we'll discuss with height or h. So height of the substrate should be a smaller value. I will explain the requirements later. First, we will see what is design of this antenna. Height should be always lesser value, and in comparative way, it should not be greater than 0.05 lambda value. And coming to width of the patch, which is a major factor in controlling impedance value, this width also should be in a specified manner. If the width is increasing means automatically bandwidth increases, but we cannot go on increasing the width of this antenna as it increases the surface waves which are not essential for our antenna concept. That we'll discuss later. Next, length. Length should be exactly half of the wavelength. So that is the value decided. And so here, when the dielectric substrate and length of the patch determines the frequency of the operation. And here the epsilon r is nothing but the dielectric constant. It is the thickness of this material, that is substrate we have been used. It should be in the range 2.2 to 12. The ground plane must have comparatively larger dimension than patch. This is just from the diagram itself we can understand. So this ground plane should be very larger compared to this patch, right? So here from this formula, we can decide the frequency dependable values. It is inversely proportional to length as well as the dielectric constant. So following these design rules, this antenna has to be designed. So by changing these values, the entire antenna operation can be controlled. And next thing is fringing effect. So this fringing effect is the main key or heart of this patch antenna. So what does it mean? What is fringing effect? We'll discuss now. So actually in the last slide, I have said some important points that is related to height of the antenna, where it plays a key role, I said. So always height of the antenna should be smaller. As the height of the substrate is increasing means automatically the unwanted or undesired radiation will be increasing. So here this patch antenna we can compare with like a open circuited transmission line. So open circuited transmission line leads to the radiation mechanism. The same thing happens here also. How that happens we will see. In the previous diagram you have a glance. One important thing I will show to you. The radiation is only along the width of the antennas, and along the length of the antenna, there is no radiation. That means simply zero radiation. Why this is happening? A simple thing. See, if you see along this lengthwise, there is no discontinuity in the structure of this patch. Whereas if you compare along the widthwise, you can observe some discontinuity type of structure. Always the radiation mechanism starts whenever there is some discontinuity type of structural format. So in patch antenna, only along the width of the antennas, the radiation mechanism can happen. Along the length, there will not be any radiation happening. And coming to here, as already I said, we can compare this to the open circuited transmission line. The same works out here. So here you can see that the waves from the patch start getting radiated from the width side. As the thickness of strip is extremely small, thus the waves that are produced within the substrate get reflected by the edge of the strip. So what does it mean? So actually in this diagram you can watch clearly. This can be compared to open circuited transmission line, which a small concept comes here. So this is the concept of voltage and current relationship between these two. How the voltage and current relationship exists here. So here you can see here at the start of the patch and the end of the patch, what is happening to voltage and currents. So here, this is the beginning of the patch. You can watch here negative charges. It is filled with negative charges. At this end, it is filled with positive charges. We can watch here the minimum voltage will be existing at this end and the maximum voltage at this point. So, and voltage and currents are out of phase regarding this concept. See, from this end, we will be providing the supply. So for patch antenna, supplies can be given in different type of models. That is another concept. So from this end, as we are providing the supply, because of the charge difference distribution of charges, automatically what happens, the movement of the charges takes place. This leads to the production of electric field. Now observe clearly at the edges, what is happening from the patch to free space, and here we have the substrate. In between, there is some air gap. So there what is happening, some discontinuity type of structure is emerged where these electric field lines start emerging into the space. That means they start coming out into the space like this, right? So this is the way the electric field lines start coming out. This effect we call it as a fringing effect. So this is the heart of this patch antenna. As the fringing effect is more, the more amount of radiation will be evolved. And you can observe one more point here. In between the patch and the ground plane, a field is formed. Here from the diagram you can watch. This is the field that is formed. But here what is will happen exactly is these electric field lines are exactly equal and opposite. So here what happens, all these field lines get cancelled out. Why? Because the currents are exactly in opposite direction and they get cancelled away. So in between these, whatever the waves gets trapped, there is nothing to come out and everything goes into the ground plane. So all this part of fields that is formed is not at all useful for us. And whatever the fields that are emerged out at the edges of this patch. See here, edge of the patch is very, very important where this diffraction and fringing effects will be taking place. At the edges, whatever the fields that are emerged out, they will contribute for the radiation mechanism. The waves that are coming out from this area are called as space waves, which are essential for radiation. The waves that are getting trapped in between them are called as surface waves, which are not at all essential for our radiation mechanism. We need to reduce the surface waves and increase the space waves. How can that happen? Just simple logic. You just imagine if we start reducing the H value, what happens? The thickness of this reduces substrate. So automatically there is a possibility for reduction of the surface waves. That's why in previous slide I said the H value should be smaller. But taking this as a base, we cannot take very, very smaller H value. Why? Because as you go on increasing the thickness of the substrate, what happens is your bandwidth becomes very, very low and your efficiency comes down. So there should be like a compromise type of design, right? So the fields, whatever the fields that are formed underneath the patch will result in fringing out the edges. So at the edges, whatever the radiation is coming out, that contributes for radiation. The currents add up in phase on the patch. Similarly, an equal but opposite direction on the ground plane cancels the radiation. As already I said, whatever the radiation coming out at the edge and extending will be added, and whatever the field that is formed in between patch and ground plane gets cancelled out, right? So here you can observe this is the electric field formation. This is the center of the patch. I have just taken the front view of this, and the field distribution will be like this. See here, one thing we can understand. The fields here can be divided into two things like transverse field as well as electric field. Whatever the electric field formed here gets cancelled, and whatever the field that is formed in transverse directions gets added. It can be compared like end fire direction as well as broadside direction. Along the end direction, everything will be added out, and along the broadside direction, the radiation will be cancelling out, right? So here, some of the important points that we need to keep in mind while designing patch is the epsilon R should have lower values for getting more fringing, and which allows higher frequencies with larger bandwidth. Why? Because here, if you increase the epsilon value, that is dielectric constant value, this leads to the more fringing. That relation already I have given here. You can observe here how the length, height, and these epsilon are related for the fringing field. And here, epsilon value with higher values reduce the dimension of the patch. But what happens? Efficiency or bandwidth goes low. That just now I have said, as the height or thickness of the substrate is changing, that has a lot of effect on the fringing or output radiation. So dimensions of the patch are finite along length and width. Yeah. Why? Because the patch that you have placed or chosen over the substrate is always have a fixed dimension, right? So the fields at the edge of the patches causes some discontinuity, and where this fringing gets started. So fringing is nothing but completely dependent on the dimensions of the patch, what we have chosen for length and what we have chosen for the width. So bringing all these things into a relation, so for fringing to happen perfectly, a formula has been designed. It is a function of ratio of L by H whose value should be greater than 1, where in such a case, the fringing effect will be reducing. So we have to keep in mind that our value, whatever the thing we are taking, should not exceed this one. And as L by H greater than 1 as well as epsilon are greater than 1, the electric field lines found mostly in substrate. So radiation is along width, not along the length of the patch. So why that happens? Already I said, because of continuous and discontinuous type of structure, this thing will be happening. So as you go with the point of this patch antennas, the most important thing we need to keep in mind is the fringing effect should be more. For having the fringing effect in increased mode, the designing of length, width, as well as height of the substrate, these three are the key factors, as well as epsilon value should be chosen in a proper way. So for all these things, certain dimensions are given. According to that, the values are to be taken. So next, these are the, here onwards, I'll just go with the overall part. So 4 different types of feeding methods are present, such as microstrip line feeding, coaxial feeding, aperture, as well as proximity coupling. So out of these 4 methods, depending on applications, any of the feeding method will be useful. And these are the list of the advantages we are having. Wherever all we can go with our microstrip antennas, like polarization wise, weight, cost, as well as usage in combination with microwave circuits and different range of frequency operations. So in that way, in many areas, it can be useful. And disadvantages wise, straight away we can say we cannot go on increase the size or dimensions of the patch, which leads to loss of radiation and efficiency reduction. The same things I have highlighted here, where the bandwidth is low, which leads to low efficiency, low gain, all these things will be happening. And mainly because of these surface waves, which are not needed, will be higher if you have the different types of dimensions for your patch antenna. And these are the list of applications you are having, so that you can just have a glance at this list of applications. Thanks for watching this video.